compound where a reaction could occur? Okay, so you have this compound. Okay, so react that with NaOH. I'll put a few more on here too. So NaOH. H3O plus, and then we'll also do, let's see, we'll also do the ethanol. Okay, so what's going to be the product of each of those reactions?
It's going to make all the NH2 groups alcohols. The NH, and then it's going to propionate this, or octanate.
Let's say one. Yeah.
Oh, I was doing it. Michael additions, there's an N, and then there's a pi bond connected to the N, so it's NC for pi bond, and then they roll this outward, and then the electrons here are attached to their graphs. I'm saying it out. I'm saying it wrong. All the first entries. These are all on.
That's just okay. What is that? That's the same.
What I do is I would always like I I started diary and everyone's providing
Is oxygen more electronegative or is nitrogen more electronegative?
Now, the periodic table, oxygen is more electronegative. Nitrogen. Okay, so how does this compound react with NaOH?
I gotta take an H away from
The
the
oxygen on the... Yep, it's like Giovanni said correctly that here we have our acid group, we know the H is an electrophile, sodium hydroxide is a base, so yeah, so the H is going to be removed using sodium hydroxide to form the conjugate base of this compound. Okay, so let's just remove this H. We have the COO minus, and that's it. How does this compound react with HCO plus?
coordinate dash. O's in the column. O's double after the column.
And there's something else. Yes, that's the intermediate. There's something else after that. Informs. Forms. And yeah, so from here, you're saying that the H3O plus, the acid reacts at the, you're saying at this one? Or at that one?
It needs to be that one.
Yeah, either one. So if it reacts at this one, what's going to happen?
Ion forms a lone pair of oxygen.
Yeah, so it'll form as your intermediate. Okay, so let's take a look at the structure here. Okay, so from here you said that it forms this intermediate, and then from there, the NH2 group into alcohols? Wait, we'll look at that in just a second. Okay, so once this forms, we have H2O, and then where can the water react? Yes, it reacts with the carbonyl carbon, and then what will we get as our product? Yeah, so once that forms, it's going to form this intermediate.
How come the ion doesn't break?
Oh, so yes, if this reacts here, this we'll have too many bonds in this carbon, so this bond can break.
Or does it, when it has the H, does the pylon break automatically and then the...
Yeah, you can do that. So you can break this bond to form the residue. You can do that. In other words, you can do this. You can do this. See, that's what you're talking about. Yeah, you can do that.
Would it matter, like on the test, which way you do
Is
it?
that again? Either way. Yeah, so once you get this, now note that what kind of reaction is this anyway? We have the water or nucleophile reacting at the carbonyl carbon, and this reaction type is in George? Yep. So once we get to this intermediate, in the nucleophilic gas substitution, remember from that previous slide, this one here, we talked about leaving groups. So what functional group contains leaving groups, or leaving group? Yeah, an alpha halide, like alpha halide, what else? What else? Thiols, alcohols, what else? Esters, and what else? Yeah, so that an ester is we classify an ester as a acid derivative. Yeah, so if it's an ester, then you can include all those acid derivatives too.
So this one's acid.
So once we get to here, this is in the middle of the nucleophilic acid substitution mechanism. So usually what happens, we get a few proton transfer steps. So for example, if we want to move this proton from here to there, and then,
There's a long transfer oxygen comes down and closes up.
okay, so you're saying this one, for example,
Yeah.
and then that breaks.
We just get right back.
Yep.
Just forms.
We just get back to where we were before.
Yeah.
So,
So just deprotonate the water.
no, so yeah, something else happens then, so one.
Your main compound will take one of those records?
Yeah, so rather than the H reacting at this oxygen, you can react at that oxygen. Okay, so we react at that oxygen, now we have this one. So let me, so now we have this. And then from there, what happens? Yeah, so now we have the H2O. That reacts there, and then that bond breaks. And then we get, for our intermediate, I'll let you guys draw the structure. Okay, so we get our tetrahedral intermediate here, and then from that intermediate, there's a few proton transfer steps, and then we get our product, and our product is going to be it's going to be,
Two acid groups?
yeah, so that's going to make this into an acid. Okay, so we'll get this as one of our products. And then what happens to the nitrogen here?
Come NH3.
Yep, it comes NH3, so look at that plus NH3. So this is a, we classify this reaction as a hydrolysis reaction. So that's a nucleophilic acid substitution, but we can also call it a hydrolysis because the water is breaking up the amide into an acid plus amine. So I know a lot of you guys are taking biology, so this is actually what happens a lot. You have, for example, if you were to ingest like a drug which contains the amide functional group, the amide will break up into the acid plus an amine. And that hydrolysis reaction. George?
The one that goes backwards from the hydrolysis, that one's called condensation, right?
Which one? This one?
So when you have like an amine and an acid, is that condensation?
Oh yeah, so you have an amine plus an acid form, that's the condensation function.
Water is a product, right?
Okay, condensation water is a product, hydrolysis of water is a reactant. Yes, remember that, so again, recognize that when you have an acid or an acid derivative, that can undergo those nucleophilic acid substitution reactions. So when we looked at that in class, we looked at this one, it was, we looked at Hey, look, this one. There's one is, yeah, so this one here, so for example, Z is either the acyl chloride or the anhydride or the ester or the amide, or actually could be an acid too. And then a nucleophile reacts with it, and that converts the acid or the ester or the amide or whatever to another acid or acid derivative. Okay, so that's what we're doing here. So we're just converting the amide into an acid plus an amide. Okay. So I think it was actually, you say what happens at this
Oh,
at
yeah,
this one?
I was just gonna ask that.
Yeah, so what happens, can the acid HCO plus react here?
Does the nucleophile from the oxygen hit one of the hydrogen? Or I guess it needs to add a proton to that first.
Yeah, so we can protonate this nitrogen to form the NH3 plus, and I think we did this in, very briefly, we did this in class very briefly. Remember that we did this, so we have this compound. So this is in the fully protonated form would be this compound works. Okay, then we said, depending on the pH, it will either form this one, and then it'll lose that proton to form the third form. So the pH will determine the form and therefore the charge on that amino acid. Okay, so we only spent a few minutes talking about that in class because we talked about that in more detail in Chem 1B. If you take like a biochemistry class, then you'll do a lot more. Apply the pKa to figure out the charge of that concentration curve. Okay, so how does ethanol and sulfuric acid react with this compound?
Form an ester.
An ester? So on which carbon does the ethanol react? Are you saying it reacts at this carbon with the acid or that carbon with the amide? So you're saying it reacts at this carbon because
Because the two oxygens and one electronegative.
which means
So the
that
side carbon is part more electropositive.
which means
It's more reactive.
yep. Yeah, so the acid is more reactive than the amide. Yeah, so Samson went through the logic on figuring out that this is more reactive. Yeah, so that's what I should say. So all you gotta say that's more reactive. Okay, so again, for this last one, when this reacts with a alcohol, we have the acid reacting with the alcohol to form an ester. That's another nucleophilic acyl substitution reaction. Okay, you guys ready for the next one? Okay, let's go with this one. Where will the reaction go with this one? This one is which one? Okay. Thanks. So where's the reaction occur here?
Oh, it's one of those
Yes, look at that.
Which we did like on penal site.
No, that was, yeah, we skipped that. That was the nuclear fluid aromatic substitution in that chapter. We skipped that. We only looked at electrical. Although there's a reaction we'll cover later when we have that arrow by. They don't worry about the fluid
Oh,
aromatic.
it's one of those things where you go in this one.
Okay, so you figure out where a reaction occurs? This compound?
And a penal group?
Okay, so I'll write down a few more reaction conditions and we can figure out what's happening here. So number one, how does this react with NaOH? And then how does it react with, say, HNO3 and H2SO4? And then we'll do another one with okay, so we'll just do with H3O plus again and ethanol and sulfuric acid.
It's an activator. But it's more indirect.
Oh, it's a moderate activator.
It's stronger activator.
So we're going to take it to the para. No, it's going to go to the ortho because the para is every time I draw a ray, I draw some pylons and a lot of things to feed them.
I just draw a circle.
I'm so good at drawing the lines. I wonder how many things are and then we should go around at the acidic hydrogens in the alcohol.
I think it's going to react on
Yeah, it could, but it could also be
Oh, it's just a song.
It's stronger activator than the
we can look at any reactions leaves.
So,
On the
and
wing,
that
which
was fast.
the group leaves.
But we're wondering about the NaOH.
The NaOH is a base of their acid.
The oxidic hydrogens on them. Okay.
I think it actually varies on the phenol, since it forms,
You think the base is
also
their
has
acid?
this, what?
You think the base is their acid base?
Basis reactant with acid.
It's a base reaction.
NaOH is a base. Does they here grab the?
It is. It is, isn't it?
Also, can act as base or acid. Just like water.
Sorry, you
I think,
rewash this.
I think it reacts more because of resonance, the conjugate base that it forms is more, the electrons are below the left more, as in the whole ring is gonna,
It's like a picture of the office. That's right. It was word for word and we didn't put copyright date, so it was not elevated.
Where is my next?
Oh, these two and those two.
So one about where you do that and put it in. Oh, it was really interesting. White.
Remember, it's not.
it makes sense.
You have to see the value. It's not like that, it's
Okay, so how does this compound react with NaOH?
Protonates.
Protonates the acid group. So will it deprotonate the OH group?
Yeah.
But which one will it more likely, or which one will it deprotonate?
Carboxylic acid.
Yeah, so why the acid rather than the alcohol?
Lower pK.
Yeah, so note that this is a stronger acid than that one.
What about the resonance stabilization of the conjugate base? So like if that phenol group is deprotonated, then would it form a more,
Yeah, it will, but even in spite of that, the carboxylic acid group is still a stronger acid.
Okay, so just PK would count that.
Because pK of an acid is usually around 5, and phenols about 15 or 14 or 15 or something like that. You don't have to remember that, those numbers.
Well, okay, sorry, given.
No.
Oh, so I wouldn't have to deal with it. Okay.
Okay, so how does this compound react with H10O3 and H2SO4? Yes, that's the nitration reaction. So on which position, on which atom will the nitro group ortho to the OH or ortho to the OH or ortho to that one? Why ortho to the OH? Yeah, because this is a strong active, so the nitrogen can be here or there.
It would take pair first, but it's taken.
Yeah, because the pair is already taken. Yeah, so that's a good thing to remember. So remember that the OH is a better activating group than than this alkyl group. Okay, what about reacting that with H3O plus? Same meaning hydrolysis of the acid to form. Yeah, just form the acid. So that's actually not a reaction. So the H3O plus does react with something. If protease, like Juan says, H3O plus is going to protonate the amine to form NH3 plus.
So it's just a plus charge.
So you get the NH3 with the plus charge, so that's it. And what about ethanol and sulfuric acid? Yes, it makes an ether. Although, can the H2SO4 protonate this one here and do something?
No.
Yes, the sulfuric acid can protonate this, but will it do anything after that? Nope. Nope. Yes, nothing. So really, you'll get that's the esterification reaction.
So the H3O plus would just reform the same acid that we have.
Okay, so know what you're doing. So you know which atoms react, so you're looking at the different possibilities and you're choosing the most likely possibilities. Yeah, I see.
What was the reason behind H3O protonating the NH2?
Oh, because NH2 is a base and H2O plus is an acid. That's an acid base reaction. Before we go, George.
Or the esterification, is that also categorized under nucleophilic?
Yeah, so see, the way I remember it, anytime I see an acid group or an acid group, I always think that my first thought is nucleophilic A substitution. Actually, if it's an acid, I think an acid base. But after that, then it's the A substitution. Okay, before we go on, could you synthesize this compound starting from benzene and any 3-carbon compound or less in any necessary inorganic reagent? So can you synthesize it from benzene? Using benzene and any 3-carbon or less organic compound. Okay, so remember, if you start with benzene, you've got to form some bonds here. Some carbon-carbon bonds. You got to form that, somehow put the OH on there. So let's see, because on the take-home portion of the final exam, I think you were asked a question on this here. Yes, so for the take-home exam, you're asked the question, if you have, what type of reactions does each function group undergo? And then you're asked to determine the functional group which is formed when a functional group reacts to another functional group.
So you would do the.
There's one on reagents, and I guess I didn't ask the question
MPS is for.
A question
Bromination.
on
So it would be like this position that, you know.
like how bonds break or how bonds form. Because we talked about that before. The question we talked about in class a few times is name one way to make a carbon-carbon bond, or name one way to break a carbon-carbon bond. I guess I forgot to ask that. Yeah, so, you know, that's a good thing. You try to anticipate what could be on a question be on the final exam. I learned that when I was in graduate school. We had to take these monthly exams. They're called the cumulative exams during my first year. And one of the professors in the division would write the exam. It was closed book, closed, no periodic table. So we would try to guess who was going to write the exam and then what kind of questions we would use. So that's what you can do on the final.
What you could do is turn into the OH at year 2 for year 3. Do a grader on CO2. And then so you have.
I also want to remind you that if you discuss any portion of the take-home exam with anyone else, that means you're working in a group with that person or persons. Because as I said before, I just don't like it when I read the same thing over and over again.
What if we looked at the group and then we had like some parts that are different from them? We also put in our different parts, or do you want us just to do one?
See, ideally, you work just one big group. Yeah, see, in other words, if you're jumping from one group to the other, then it makes it, it's just the easiest to just join one group. And then you're like a free agent. You just jump from one group to the other instead of sticking with one. Yeah, like you had double agent, triple agent.
For Friedel crash calculation, can you use an alpha halide but with two alpha, two halide on it? So two ends would have a chlorine attached to it. Can I do that?
You can do that.
And either one will react with the ring.
Yeah, you can do that.
Year 2 to add and then adapt it to, we either adapt it to nitride or CO2. Or, yeah, or what you can do is a micro addition thing. Okay. Could I just do excess but if you don't want to change the word OH. Well, then, no, you do. No, you don't. You don't. So you would not want to.
What I would want was if you have access to something too, there, then tell you how to just put that in, which is in there after
But just to be clear, that's what
Oh, yeah.
I just don't want to, I just want to block it as best I can. But now I'm a little stuck because I need to move my guy over a bit. You don't have an oxygen, so I think I'm going to play with it.
What were we trying to do?
How do you have a phenol? You have to use a nitrite pump.
Oh, yeah, see, we can look at that. That'd be a different airbags, so we can look at that. Just want to figure a different way to connect this part to
The nitrite pump.
yeah, because with that nuclear airbag substitution, we actually need,
CO2.
you need strongly deactivated groups on the brake valve. The OH is actually too strong and active, so it's hard to do it that way. Yeah, we skip those airbags, nuclear airbags.
I don't know why it's doing it, how it's.
But on the, as an arrow route, though, like
So you dealt with the other guy first.
Use NPS for I didn't know how.
See, if you want to put the roaming, you don't want to do the GR2.
I've never seen a way like that. You can aside using the diet zone.
I know this is one of those things that's a balance.
Thank you.
Yeah, so you're doing a nuclear airbags substitution to that arrow diazone. We skip the nuclear airbags substitution first. So you did arrow diazone. That was this one, you had to get the middle arrow to go from here to this one. And then then from there to this one. Then from there, then you can react that several reactive ends to action.
Yeah.
There's no nitrile.
It is.